In this video, I'm going to discuss about the mathematics behind the generalized linear model or the GLM. In the traditional models, the model takes the form like this: yi is xi beta plus the epsilon, where epsilon is the error term. Xi is the matrix of all the covariates or independent variables, whereas beta is the matrix of all the parameters, the slope and the intercept parameters in the matrix form. Now the assumption here is that the error term is normally distributed with mean 0 and variance of 1 in most of the times. Well, in this kind of a model, there are a number of problems. First thing is that the assumption of normality doesn't hold all the time. So sometimes we'll have measured observations. So that could be count, that could be a quantity variables, so which may not follow non-normality. So assumption of normality is unrealistic many times. The second problem that usually is encountered is that we may not be able to, we cannot use the response variable which takes values within a range. For example, while modeling probability has to be always between 0 and 1. So that's the restriction, the upper bound and the lower bound. The problem is that the covariate can take any value. It can take values from minus infinity to plus infinity. So you cannot use this kind of a model to model for probability of something. So if the response variable or the intention is to model for probability, you cannot use the traditional linear models, which has a range between minus infinity to plus infinity for the covariate multiplied to the estimates value, which is the expected value of y. In GLM, and the last problem is the constant variance. Well, this is an assumption also, but this is unrealistic. So the variance of data usually is not constant all the time. So because of these three problems, sometimes traditional models don't perform well, or there tend to be some sort of a biasness. So GLM comes as a rescue. The mathematical form it takes is that the expectation of y is a function of g, and the g is the link function. So it takes this kind of a form. Well, the expectations is similar to the traditional model, except the fact that we have a link function here, which relates the average values or the expected value to the y values or the response variable. So and that is sometimes most of the times non-linear in nature. And g belong to the class of probability functions known as the exponential class of probability functions. Now you may need to go through what are the exponential class of probability functions. For more details you can search in web. So and this is estimated using the GEE estimation. Now after doing the estimation, we can also find out the standard error, confidence interval, and we can do the hypothesis testing pretty much the same way that we do for traditional models. So there is hardly any change for estimating the standard error, confidence level, or doing the hypothesis testing.